Welcome everybody to our paper presentation with the title Evaluating and Redefining Smartphone Permissions with Contextualized Justifications for Mobile Augmented Reality Apps. My name is David Harborth. I'm from Goethe University, Frankfurt in Germany, and I wrote this paper together with Alisa Frik from ICSI. Before we begin, I would like to provide a common ground of understanding of what augmented reality is. Here, one of the most cited definitions is the one by Atsuma et al. From 2001. The author stated that AR combines real and virtual objects in the real environment, runs interactively and in real time, and aligns the real and virtual objects with each other. The point here is the real environment, which differentiates AR from other immersive technologies such as virtual reality. But why should we care about it? Well, there are several tech leaders, for example, stating that it will become the next big technology, even with the potential to substitute the smartphone in some time. And even now we have numbers stating that over 80 million users in the US regularly use AR features primarily on their smartphones, as it's currently the most affordable and widespread option for accessing AR. And thus, in our work, we particularly focus on these mobile augmented reality apps on smartphones or tablets and on their end users, not on the bystanders. Why should we care about privacy in this area? Well, what we see here is that compared to non-MAR apps, to regular smartphone apps that we know from before, augmented reality apps pose greater privacy and security risks. First, because AR requires more sensor to function and thus aggregates more of the associated context-dependent data types. A well-functioning AR system must always be aware about the context of its user, or the real environment in which the user moves, as well as the real objects in it. Thus, many sensors and data processing techniques need to be employed for a realistic user experience, making AR apps' data collection practices more intrusive than those of non-MAR apps. Second, malicious MAR apps can realistically alter digital objects and information presented to the user without their knowledge and thus deceiving them. Third, we see that the heavy reliance on the camera input goes in hand with only limited feedback of what is actually captured by the camera and used by the MAR app. And thus we have even more limited transparency compared to MAR apps, to non-MAR apps. One of the most common ways of communicating and controlling apps' data collection practices in the smartphone ecosystem are, of course, permissions. And these permission systems have been heavily criticized in the past for not providing contextual clarity about resource accesses. And this is exactly where our work on MAR apps privacy begins. So we basically explore the potential of a modified permission system for MAR apps by posing the four following research questions. First, we ask to what extent the information provided in the permissions affect users' understanding of the MAR app's resource and data accesses. Furthermore, we ask what users' expectations are about the impact of these permissions on the app's performance. Second, we evaluate to what extent the information provided in the permissions affect users' privacy concerns regarding the MAR app. Third, we analyze the willingness to grant access to the different permissions, as well as the intention to download the MAR in light of the presented permissions, in light of the requested smartphone resources by the permissions that we show the users. Finally, we combine the results of the quantitative and qualitative analysis in order to derive practical recommendations for increasing transparency of smartphone permissions for MAR apps. To answer the research questions, we conducted 2 between subjects survey-based experiments with a total of 481 participants, in which we assigned participants to 3 experimental groups and compared their opinions and choices. we presented participants with a scenario with a fictional mobile augmented reality app that can help to redesign a room or outdoor space. For example, put a chair into the room and see how it looks, so basically kind of furniture app. And then we showed them a list of permissions this app is asking for. And the first group, the control group, only saw the permission labels. So for example, they only saw microphone. The second group saw the labels plus a short text providing a generic information about the permission. For example, microphone is required to record audio without explaining why a measurement app needs it. In the third group, in the contextualized justification group, that's how we called it, we provided context that meant concretely we added the reason why the permission is required at that point. So we explained why the MAR app requires access to certain data. For example, in our microphone example, we said the microphone is required to add voice notes to the measurement photo. Then we asked participants about their willingness to grant permissions, privacy concerns, app download intentions, and a few open-ended questions about what additional information they would need for a better understanding of the app's data use. Based on the results of study 1, we reworked our justifications to match the linguistic complexity of the contextualized and non-contextualized justifications, because we saw that there were differences and we needed to control for those differences in order to factor out potential effects that the contextualized justifications were harder to understand. Then I would like to provide you a brief overview of the permissions we tested. So we included 7 existing permissions and we introduced 9 new permissions that cover sensors and data practices commonly used for MAR apps, such as LiDAR scanner or face recognition. Our results show that participants in the condition presented with contextualized justifications show higher levels of understanding of the app's data practices and perceive higher informativeness of the permissions. Furthermore, contextualized justifications mitigate privacy concerns, and we also find that some permissions raise substantial privacy concerns, such as location, contacts, microphone, speech, and face recognition. Furthermore, we find, based on our qualitative analysis of the open-ended text questions, we find that participants in the conditions without justifications requested more clarifications about what data is collected, how data are used, whether they can deny individual permission accesses, and how the declining of permissions affect the app's performance. Regarding our third research question, we find that contextualized justifications do not directly affect our dependent variables, so willingness to grant access and download intentions. However, we find that there is a mediation in place via privacy concerns and perceived informativeness. We visualize these mediating effects in the graph here on the slide. Here we can see that contextualized justifications have a negative effect on privacy concerns and on the perceived and a positive effect on the perceived informativeness. And the mediating positive effect basically exists as decreasing privacy concerns and higher levels of perceived informativeness in some increase the willingness to grant permissions. Regarding our final research question about transparency and measures, we find that transparency can be increased first and foremost by including the permissions common to MAR apps that are perceived by users as dangerous, for example, face recognition and speech recognition. Second, we find that providing contextualized justifications helps participants in understanding apps' functionalities and data use. Here we suggest to not only provide information about what data are accessed, but also when functionalities and data are accessed by the MAR app. For example, the question needs to be addressed here when an app starts processing the camera input. Is it doing it right at the start, or when you begin placing virtual objects such as furniture into the real environment? That is currently totally unclear. Furthermore, in an ideal environment, in an ideal world, the accuracy and the correctness of justifications should be enforced by app stores and regulations. Furthermore, linguistic complexity should be taken into account in order to provide users with an easy to understand text set, even for users with low literacy. Additionally, short explanations of novel sensors or functions should be included, and the visual appearance of those explanations and the permissions should be improved. For example, what we found would be a good way are expandable text boxes, for example, making it easier for users who do not want to read something to skip the information and avoid permission fatigue. Lastly, it should be required to show users information about whether permissions can be denied and what the consequences on the app functioning are. Our key takeaways of this study are the following. First, yes, we find that justifications are useful tools for transparency. However, they need to be meaningful, easily understandable, and tailored to the specific context of the app. Second, new permissions common in MAR apps raise significant privacy concerns and should be included in the permission systems. Third, we find what we call the knowledge concern gap, which means that some of the newly proposed permissions, such as accelerometer or gyroscope, do not raise significant privacy concerns. However, prior work and media reports showed us that these sensors can be critical for users' privacy. For example, they can be used to infer a phone's password or eavesdrop on the audio output of the smartphone. However, users do not really understand, apparently, the associated threat model and risks with these sensors. Thus, they need to be informed in order to understand the potential risks. And one way is the introduction of contextualized justifications as well as clarifications and explanations. In future work, we recommend conducting cross-country comparisons to evaluate differences in users' perceptions and understandings regarding MAR apps permissions. In addition, here we relied on a hypothetical scenario with a controlled experimental design. Future field experiments, for example, could improve our work and our validity of the results by using prototypes of actual apps from different categories with which users can really interact, and this would help to evaluate the ecological validity of our results. That was our presentation. Here are our references. Thank you very much for your attention. If you have any questions when watching this video, please feel free to contact me via this email address.